Okay, next kind of objective is to talk about the periodic properties of trig functions. And some of this is kind of marked over here, but there's the word periodic before the word properties. And periodic, if something is periodic, it repeats every so often. And you may recall when we talked about coterminal angles, that coterminal angles have by definition the same terminal side, and therefore coterminal angles have the same trig function values. And this kind of relates to that. So for example, what this chart is telling us is that it says the sine of theta plus 2 pi, or if we were in degrees, it would be the sine of theta plus 360, is the same thing as the sine of theta. And let me just kind of illustrate by way of just diagram real quick here. Let's put down a coordinate system here. And let's draw in here like a 30-degree angle. So here's a 30-degree angle like this. Okay. Now, again, let's pick a coterminal angle. Let's from the 30 degrees, let's go one full rotation around and stop at the same terminal side. Well, that's a 390-degree angle, right? Because we were at 30 degrees and you go one full rotation past that, so that's 390. Well, we know that those trig function values are the same. The sine of 390 is the same as the sine of 30, and the cosine of 30 is the same as the cosine of 390, and so on. And so, again, getting back to the coterminal angles here really clue us in as to what this is saying. Now, how often these trig function values repeat depends on which function it is. I have the ones circled in this thick red marker here. Those are ones that have a period of 2 pi radians, or 360 degrees. In other words, they repeat every 360 degrees. Now in blue over here, I have the two functions that repeat every pi radians, or 180 degrees. And that's the tangent. The tangent and the cotangent both have a period of pi, or 180 degrees. So let me explain how this works. So if, for example, this number 23 here, they want us to find out the sine of 405 degrees. They want us to find the exact value of that without using a calculator. So let's take sine of 405. Okay, with that. Now, if you look at our chart, it says that, now we're in degrees, so it says here that, the sine of theta plus 360, or 2 pi. So the period of the sine function is 360 degrees. Every 360 degrees, the sine value repeats. So if I were to take away from this angle, subtract off 360 degrees, then I would find another sine value that's the same. So this would be the sine of 405 minus 360 is 45. Again, how did I get that? Well, I subtracted off one period of the sine function from that. So therefore I know that 405 degrees and 45 degrees are coterminal. Therefore they have the same trig function value. So now what's the sine of 45? Well, radical 2 over 2, right? Okay. And you could do the same thing with, so that's the answer. What's the sine of 405? Radical 2 over 2. So with number 28 here, so this is 23, number 28, the secant of 540, well, let's find out what's the period of the secant function. Let's go up here. Secant is one of those that also has a period of 360, or pi, or 2 pi. So that means I could subtract off 360. Well, 540 minus 360 is, I think, 180. So this would be, it's the same thing as the secant of 180. Well, I really don't know what the secant of many angles are. I don't memorize that. But I do know that usually the sines and the cosines at the very least, if not the tangents also. So I can use the reciprocal here that will help us out. What's the reciprocal function of secant is the cosine. So the secant of 180 is the same thing as 1 over the cosine of 180. Well, what's the cosine of 180? If you're not sure, take a look at that unit circle. Over here, here's 180. The cosine is the x-coordinate, so negative 1 is the cosine of 180. So this would be equal to 1 over the cosine of 180, which is negative 1, and that whole thing is negative 1. So the secant of 540 is actually equal to negative 1. We just use the periodic nature of the trig functions to get that. Last one here, tangent of 19 pi over 6. Okay, I don't know what that angle is in degrees, but we can take care of it here. We can say 19 pi divided by 6 and convert that to degrees by multiplying by 180 over pi. And so that would be 570 degrees. So this is equal to, converting it to degrees, a tangent of 570 degrees. Well, I don't have any idea really what the trig function values for 570 are, but I do know that 570 degree tangent has a period of 180 degrees. It repeats. The values repeat every 180 degrees. So if I get my calculator back up here and type back in my 570 degree angle, subtract off 180, and keep subtracting off the period of 180. Oh, sorry about that. So we got 390 minus 180. I keep subtracting off 180 until I get down to an angle that's usually acute or something that I'm familiar with. So minus 180. Right. So now, I kept subtracting 570. I subtract off 180, 180, 180 until I got an angle in the first quadrant, an acute angle of 30 degrees. So this tells me that the tangent of 570 is exactly the same as the tangent of 30 degrees, right? Well, I might not know what the tangent of 30 degrees is off the top of my head, but I do know that the quotient identity says that the tangent of any angle is the sine of that angle divided by the cosine. So this would be the sine of 30 over the cosine of 30. Okay. And from my unit circle, or from the triangles that we've looked at before, 30 degrees, right, the 30 degrees up here, the sine is 1/2. Remember, the y-coordinate is the sine. 1/2 divided by radical 3 over 2. So 1/2 is the sine, radical 3 over 2 is the cosine, so this would be invert and multiply. So this is going to be 1 over radical 3 will end up being, what, radical 3 over 3, I think, when you rationalize that. So there, using the periodic nature, periodic properties of these trig functions, tells us how we can come up with these exact trig function values for angles that we're not familiar with.